In my last video, I used a FLIR thermal imaging camera to observe the spread of heat on an aerated concrete block. I was so impressed with this gadget, I felt it deserved a dedicated video. So today we're going to compare this FLIR ONE Gen 3 camera that costs $200 on Amazon with this FLIR ONE Pro camera that costs $375. They measure 2.7 by 1.3 by 0.6 inches. The Gen 3 camera weighs 34.5 grams, while the Pro camera weighs 36.5 grams. I bought iOS versions, but you can also find Android versions of both products. They connect to iPhones with an adjustable male lightning port that can be moved up or down to account for the thickness of phone cases. The cameras run on a battery that lasts about 40 minutes and takes an hour to fully charge. Every package comes with a USB Type-C charging cable and a padded carrying pouch. To use the FLIR thermal camera, plug it into your charging port and tighten the dial. Install the FLIR ONE app on your phone and then open it. Hit the power button at the bottom of the thermal camera and wait a few seconds for it to connect and calibrate. Let's first take a look at this GE natural gas water heater inside my home. The exhaust vent through the ceiling glows bright yellow since it is hotter than the surrounding walls, which are a bluish purple. The pipes carrying hot water and the combustion chamber at the bottom of the water heater also glow bright yellow. These gadgets are pretty incredible, but we don't want to just look at pretty pictures. We want to figure out how they work, right? So, FLIR is an acronym for Forward-Looking Infrared Camera. Teledyne Technologies, who owns FLIR, sells devices for surveillance, border and maritime patrol, search and rescue, etc. Regular daylight cameras and the human eye both capture visible light, 380 to 760 nanometers. Visible light bounces off objects and hits a detector, like a digital camera sensor, a piece of film, or our retina. These detectors turn light into an image. On the other hand, thermal imaging cameras detect infrared energy, or heat, 760 nanometers to 1 millimeter. All objects, whether cold or hot, emit infrared energy. Detectors like these FLIR cameras turn this energy into images. Both the Gen 3 and the Pro devices have two cameras, one for visible light and another for infrared. The images are overlaid with MSX or multi-spectral dynamic imaging technology. This enhances thermal images and makes them more recognizable. The Gen 3 camera can measure temperatures from -20 to 120 degrees Celsius or -4 to 248 degrees Fahrenheit. The Pro camera can measure -20 to 400 degrees Celsius or -4 to 752 degrees Fahrenheit. That's 3 times higher. For residential applications, the cheaper Gen 3 camera should suffice. The Pro camera is more useful for industrial applications, like measuring boilers, kilns, or furnaces. To see the change in temperature on the cameras, I ran hot water down the sink for a couple of minutes. You can see the P-trap and the sink rapidly change color from a cooler purple at 70 degrees Fahrenheit to a bright yellow at over 80 degrees Fahrenheit. Images on the Gen 3 camera are 80 by 60 pixels, while the Pro version is 160 by 120 pixels, 4 times better. Higher resolutions means that each image contains more information and more accurate measurements. These resolutions still seem very low compared to monitors and phones, which have a 4K resolution. The reason is that thermal imaging detectors capture longer wavelengths than visible light, so each sensor element is significantly larger. That's why thermal cameras have a much lower resolution than a visible light camera. I captured my uninsulated attic ladder with both cameras. As you can tell, footage on the Gen 3 camera isn't as sharp as the Pro camera, which has 4 times the number of pixels. Related to resolution is spectral range, which is the range of wavelengths that the sensor in a camera detects. Both of these cameras are long wave with a spectral range of 8 to 14 micrometers, but their pixel size is different. The Gen 3 camera has a pixel size of 17 micrometers, while the Pro camera has a pixel size of 12 micrometers, so it can fit more pixels in an image. I was curious to see the heat loss through the ceiling of my dining room since it is the hottest room in my house. Insulation on the sloped portion is so poor you could see the outline of each 2x4 wood stud. The interior walls and ceilings didn't have any hot patches though. Thermal sensitivity, or noise equivalent temperature difference, describes the smallest temperature difference you can see with the camera. The lower the number, the better the thermal sensitivity of the infrared system. The Gen 3 camera has a thermal sensitivity of 150 millikelvins, while the Pro is 70 millikelvins. This was obvious when looking at a hot ceiling fan that's next to a cold air vent. The color gradient of the Gen 3 footage on the left isn't as detailed as the Pro footage on the right. If you use the thermal camera in front of a reflective surface like a mirror, you will see objects in front of it rather than measure the temperature of the mirror itself. This is because of the emissivity of mirrors, which is a measure of how well an object reflects heat. An emissivity value of 0 is a perfect mirror that reflects all heat. An emissivity value of 1 is a black body that perfectly absorbs all heat. Both cameras have a fixed focus of 15 centimeters to infinity, so they are always in focus. You do not need to manually adjust them. However, they have a relatively slow refresh rate of 8.7 Hz, which can make the video seem laggy. This is a government and trade regulation. It's not something FLIR can control. I love that FLIR is making professional technology available to the masses. These are going to be very useful during my home remodel because it's going to help me find trouble spots. For example, I found this one weird hot spot on the ceiling of the master bedroom. I just can't figure out what it is. There are no roof penetrations or vents in that spot. I'm going to have to get into the attic and crawl to the area to figure out what's going on. Another trouble spot is the attic fan, which is controlled by these two switches. I might have to remove the entire fan and patch it up, or add some removable insulation. This is a 45-year-old home, so I have to accept that it's not going to be properly sealed and it's going to have some issues. However, I can address easy fixes such as replacing attic fans, attic ladders, and the windows. Fortunately, all the exterior walls seem to be very well insulated. There's another thermal camera in between these two, and it's called the FLIR ONE Pro LT. It costs $269 on Amazon. But it has a lower thermal sensitivity and lower resolution, so you might as well just get the Gen 3. I love the better resolution of the Pro and the temperature range in its live view. Both the cheaper Gen 3 and the more expensive Pro are excellent devices, so just buy what fits your budget. Let me know if you think I should do more product reviews and if there are any other gadgets you're interested in. I'll link all these items in the description below, as well as my Patreon page. If you can support me, I'd really appreciate it. A big thank you to everyone already supporting me. Don't forget to hit the like button and subscribe to my channel. Thanks for watching. See ya.